All right, good afternoon, guys. So today's lesson is going to be about finding indefinite integrals. Indefinite means that when we take the integral, there's no bound on either side. So before we were looking at integrals that would run from like 1 to 3 or -2 to 8 or something like that. And so we would get actual number values for the for how much area is underneath of the curve. But what we're going to do today is we're going to provide a formula essentially. So if we had a curve and we wanted to figure out how much area was underneath the curve, you could use this equation to calculate it based off of what the two end bounds would be. So just like when we were doing derivatives, we would find the derivative at a single point and give the actual answer. But then we could also find the equation of f prime, the derivative. So for any x, essentially that's what we're doing here as well. So suppose we want to find capital f of x, whose derivative is lowercase f of x equals 3x squared. What would f of x had to have been so that this would be its derivative? Okay, so thinking about what would have happened, we would have had some function, right, to the power. We had x to a power, and what happened to that power is the power dropped down, and then it subtracted by 1. And so if we have an x squared at the end, what power did this have to be? Well, this had to be 1 more power of 3, right? And so if you think about the derivative of an x cubed, the 3 comes down in front, and it turns into a 3x squared, which is what we have here. So capital F of x would be equal to x cubed. Now there's one more condition though. When you take the derivative of x cubed, there could have been plus or minus some number here, right? Some number. So if you were to take the derivative and this was just a constant, it would be 3x squared. And then the derivative of a constant is always equal to 0. So we don't know what this number is. Unless they give us some more information, we'll never know what that number is. So the real question is hey, what is that number? And what we're going to do in this class is if we don't know and we can't figure it out, we're going to go ahead and say, hey, there's a constant there. And so kind of what this whole thing right here is saying is that there's always a plus c. There's a constant. So after you do any kind of indefinite integral, you always have to include this constant value. There's going to be some, sorry for all the bells. There's going to be some problems that you'll see where you can find the constant, but then there's going to be some where we just don't have enough information to find the constant. So when we integrate, there's always a constant because the derivative of a constant would be 0, and you wouldn't see it in your equation that you'd be integrating. You can always denote it as a plus c. You don't have to do any like fancy subscripts or anything crazy like that, all right? All right, so here's some basic integration rules. If you're integrating 0, you just get a constant because the derivative of a constant is 0. If you're integrating a constant, this is technically a constant. They don't use c because we already use c over here. So they're just saying a k, some number k, then its integral is kx because if you take the derivative of kx, you would end up with just k, right? And still you see that plus c there. And then a couple of reminders from what we talked about before. If you have a constant inside the integral, you can pull that constant out before you take the integral, and this is actually really helpful in a lot of cases. Also, if you have two functions, two things being added together, you can take the integral of each one separately with an addition. Same thing with the subtraction. And then this one is really kind of crazy looking, but it's really not that complicated. This is the polynomial one. So if you have x to the power of n, so x to some power, its integral is going to be take that power n and add 1 to it. And then to make sure you get your coefficients to balance, you divide by whatever that new power was. So for example, going back up to this one, we had 3x squared. You could find its integral by adding 1 to the 2, so that's how we got to the 3, and then dividing this by 3, and 3 divided by 3 is 1, which is why there's a coefficient of 1 there. All right, and then don't forget, still have the plus c, right? Plus c. Okay, so we're going to go ahead and find each of the antiderivatives. Antiderivatives is the same thing as saying find the integral. Sorry, I need to adjust this real fast. Hold on. All right, this should be good. Okay, so if this is 3x and we're taking the integral with respect to x, that's just what the dx means. We're going to add a power to the x, so that'll be an x squared, and then you're going to divide by 2. So in the front, you'll have 3 divided by 2. And then don't forget, at the end of this, you need a plus c. So if you're taking the integral of 3x dx, you'll have 3 over 2x squared plus c. If you ever want to check to make sure that you did it right, take the derivative. Go from here to here to take the derivative. All right, part B, we have the integral of 1 over x cubed dx. This is actually easier to write it as a negative exponent, just like if we were taking a derivative, easier to write as a negative exponent. And you follow the same pattern. Add 1 to the power. Now be careful when you're in negatives and you're adding 1. That's technically negative 2, right? And then divide by negative 2. So that would be 1 over negative 2, or negative 1/2. And then don't forget, you need a plus c. You could rewrite this to negative 1 over 2x squared plus c. All right. Up next, we have the square root of x. So this would be the integral of x to the 1/2 power dx. And so to the 1/2 power, you would add 1. So 1/2 plus 1 is 3/2. Divide by 3/2. So there technically is a 1 right here. 1 divided by 3/2 is 2/3. It's the reciprocal of that. So if you ever have to divide by a function, multiply by its reciprocal and you'll be fine. And then last but not least, don't forget to include your constant that could be at the end of that. Like there could be a plus 1, plus 8, plus 50, minus 2, anything like that, just kind of chilling at the end. All right, here is the next one. This is a cube root, and then this is just x minus 4. And so the best thing to do here is to go ahead and distribute this. So just like when you take the derivative, sometimes it's easier to just distribute ahead of time and then take the derivative, as opposed to using the product rule. When you integrate, sometimes it's easier to distribute first before you try to do any kind of like reverse product rule, quotient rule, stuff like that. And we will learn how to do kind of reverses of things next week. All right, so this is x to the 1/3, and it's distributing to x. And what you do with those is you add their powers, right? This is x to the 1st and x to the 1/3. So add those together, you would have x to the 4/3. And then distributing again, you would have minus 4x to the 1/3 dx. And then go ahead and add to the power and then divide by the new power. So x to the 4/3, you're going to add 1 to it. So you're adding 3 over 3. So you'll have 7 over 3. And you're dividing by 7/3. So this will be 3/7 in the front. For this one, we are adding to the power. So this will be x to the 4/3 power, adding 1. And then dividing by 4/3, which means multiply by 3/4. So think about this. We have 4 already. Timesing by 3/4, the 4 and the 4 in the denominator will simplify, leaving us with just a 3. And then at the end, don't forget plus c. You will lose a ton of points on the AP exam if you forget your plus c's. All right, here is the next one. Once again, just like on the last problem where distributing made this a lot easier, go ahead and do some division here because there's only one term on the bottom. You can do x divided by the square root of x and 1 divided by the square root of x before you integrate. X divided by the square root of x is actually x to the 1/2, or the square root of x. So think about this. This is power of 1. This is power of 1/2. And if you're dividing, you would subtract them. So 1 minus 1/2 is 1/2. And then when you do 1 divided by the square root of x, that is just x to the negative 1/2. And the derivative with respect to x. So add to the power, divide by the power. So add, do you notice how I skip a space, a little bit of space for my coefficient, and I do the power first? Don't try to divide by the new power before you write it. Like, write it out first. It's going to make your life so much easier, and then just go back and fill in the gap. All right, so add to the power. So if we're adding 1, we would add 2 over 2, which is 3 halves, and divide by that power, so flip it over, 2/3. And then for this one, add to the power. So negative 1/2 plus 1 is a positive 1/2. And then divide by that power, so that would be 2 over 1, so just 2. And last but not least, there is a plus C. All right, here is the next one. Same thing as before. This would be some kind of like chain rule going on here, and we're going to talk about what the chain rule looks for integrals next week. And so as of right now, the easiest thing is to just go ahead and multiply this out. So do t squared plus 1 times t squared plus 1. So our new integral is actually going to be t to the 4th plus, you'll have 2t squared plus 1. And this is dt because my variable is not x anymore, it is t. And once you multiply that out, this integral is actually not that bad. So add to the power, divide by the power. So that'll be a 1/5. Add to the power, divide by the power. So it'll be 2 over 3. And then add to the power. Well, if it's just a constant, that's when we add the variable and divide. It'd be 1 divided by 1, so just 1. And you still have a plus C. All right, so that's kind of integration for some polynomials. All right, so remember how I said sometimes they'll give us enough information that we can go ahead and identify what the C value is, and that is actually what is happening on example 2, is we'll be able to find f of x every single part. We'll be able to find all the C's as well. So we have f double prime is equal to 3, f prime of 2 equals 5, and f of 2 equals 10. So this is our starting function right here, f double prime. This is what the second derivative equals, so we're going to work our way backwards. So if you take its integral, you would get f prime of x. And the integral of 3 is just 3x plus c. And so here's where we're going to go ahead and find that c value. So we have f prime of 2 is equal to 5. So when we plug in 2 for x, we'll get that that equals 5. So we have the equation 5 equals 3 times 2 plus c. So that implies that c has to be what number? Well, this is 6, and to get to 5, we would subtract 1. So c is negative 1. So our f prime of x is equal to 3x minus 1. So if they give you a coordinate point, you can go ahead and use that coordinate point to find the c value. All right, we are looking not for f prime though, we're looking for f. So guess what? We have to do that process one more time. So f of x would be the integral here. So we're going to add to the power and divide by the power. And then the negative 1 would become negative x. Add an x or add to the power. Right now it's x to the 0, so we'd add. And then divide by 1, so negative 1 still in the front. And then that also has a plus c. Anytime you take an integral, you have to include the plus c. I know we included it over here, but we did a second integral, so we have to include it again. And then you're going to go ahead and find c for this equation. And you're going to use the fact that f of 2 equals 10. So this will be 10 equals 3 halves 2 squared minus 2 plus c. All right, so c is going to equal, this is 4. 4 times 3 halves is, well, the 4 and the 2 will simplify to a 2 times 3, so that'll be 6. 6 minus 2 is 4. 4 plus what number gives us 10, and that is 6. So here is your final solution. F of x equals 3 halves x squared minus x plus 6. All right. So sometimes they'll give us enough information we can find c, and sometimes they don't. We just have to roll with the constant c. We're going to go ahead and move on to trigonometric functions, so the derivatives of the integrals of trig functions. So always remember, I had this little chart, right? Sine, cosine, negative cosine. And as you move this way around, you're taking the derivative, while as you move this way around, you're taking the integral. So the integral of cosine is sine of x. Don't forget, there's a plus c still. Well, the derivative or the integral of sine of x, if you go back, sine of x would be negative cosine x plus c. And then here's where you just have to know your derivatives. So what did we take the derivative of to get cosecant squared? Well, that's a negative cotangent of x plus c. And typically we say cotangent of x, its derivative is negative cosecant. So if this is positive, then it would be a negative cotangent. So you can kind of interchange those negatives back and forth. What do we take the derivative of to get tangent squared? Secant squared. That was the tangent of x plus c. To get cosecant of x, cotangent of x, that would be a negative cosecant of x plus c. And last but not least, secant x tangent x dx, that integral would be the secant of x plus c. All right, so we have a couple of examples of integrating with these trig functions. So here's the first one. We have 2 times the sine of x dx. And so this is one of those cases where we're going to use the property where that constant 2 that's being multiplied can just move to the front. So we can say 2 times the integral of sine of x dx. Because we don't know the integral of 2 sine of x, but we do know the integral of just sine of x. So that 2, because it's being multiplied, can move to the front. And so our answer would be 2 times the integral of sine of x, which is negative, so I'm going to make it a negative 2, cosine of x, plus c. You do not need to worry about plus or minus c. You just plus c, because if c is positive, then it would be plus, right? If it's negative, then that's when it would turn to its minus. So always just plus c. So even if you think something funny is going to happen and you end up with a minus something c or whatever, just c. So for example, technically this would have been like 2 times the integral. Let me rewrite this to show you what I'm explaining. This is the right answer. It's not wrong. But this would be 2 times negative cosine of x plus c, like this, right? 2, and then this value here, this integral is written like this. So we say negative 2 cosine of x, but we do not write 2c because 2c is the same as a constant. So instead of saying 2c or 8c or minus 1/2 c or whatever might happen on this, you just leave it as a c, just a constant. You don't need to worry about any of those details of what's happening to the constant, because if you take a constant, you multiply it, you do anything like that, you're still just going to have a constant. So we just wrap all those constants up into one pretty constant, 1c. All right, here is the next one. And in terms of integrals, we don't really know what in the world is going on here, but we do know sine and cosine, that we can change those into some of the other trig functions. So I have a sine and then I have 2 cosines in the denominator. So I'm thinking sine over cosine, that's a tangent, right? Tangent of x. And then the extra cosine in the denominator, that would be 1 over cosine, which is secant of x dx. And this is actually this one right here, isn't it? Yes, they're reversed, but remember it's just multiplication, so it doesn't really matter. So this integral is the secant of x dx. Or sorry, not dx, plus c. What was I doing? The integral is secant of x plus c. All right, so some more basic integration things going on here. If you have the integral of e to the x dx, that is just e to the x plus the constant, because the derivative of e to the x is e to the x, so going backwards, it would still be just e to the x. And this one's a little bit more complicated. So this is when it's not e to the x, when it's some other number. So maybe like 2 to the x or 5 to the x or 1/2 to the x. It's going to be equal to whatever that base is, 1 over the ln of that base times this is the same, right? A to the x is the same as that. So times the base to the power of x. And then we don't forget about the plus c. All right. So 5e to the x can be written as, because we don't know the derivative or the integral of 5e to the x, it would be 5 integral of e to the x dx. So that 5 can move outside. So this would be 5 times derivative or integral, of e to the x is e to the x plus the constant. And what we have here is 5e to the x, and this would be plus 5c, but we don't really care if we take a constant and multiply it by other constants. We just tie that up into 1c. So this is 5e to the x plus c. All right, this one over here follows this formula that we have. So this is 6 to the x. So in this case, a is 6. So we would say that this is 1 over the ln of 6 times 6 to the x plus the constant, which can also be written as, since this is a fraction times an integer, or not an integer, but a number like that, just over 1, essentially a numerator, you can write it as 6 to the x ln of 6 plus c. So either one of these would be acceptable. If it's a multiple choice question, most likely the answer would be written like that. All right, we are going to continue to move right along here. So integration of 1 over x. So if you have the integral of 1 over x, its integral is the ln of the absolute value of x plus c. Because if you remember, the derivative, I'm just going to write it off to the side, of the ln of x is 1 over, sorry, you can even see that, is 1 over x. So whenever you have a 1 over x, it turns back into a natural log. It does turn into the absolute value because you cannot take the natural log of a negative number. So we have to restrict that x in this case so that it stays positive. So you're always going to put those absolute values in there. One more thing, you might try to think that, hey, can't we just use this as a power rule? Couldn't we just instead do the integral of x to the negative first dx, right? Because that's all 1 over x is. And the problem here is if you add to the power, you would get x to the 0 power, but then you'd have to divide by 0. And so this is not possible because when you follow those properties, you get to divide by 0. And this just doesn't work, right? The x to the 0 is fine. That's just 1. But then you end up with 1 divided by 0, and we all know it doesn't work. All right, so example 6, find the integral of 5 over x dx. So once again, this 5 is just a constant, so technically it can come out of the integral. And then we can take the integral here. We know that's the ln of the absolute value of x plus c, and all of that technically is multiplied by 5. And so this is just 5 ln of the absolute value of x. And then 5 times a constant, we're just going to go ahead and say that that is still a constant. So you can go from here to here and kind of skip that step. So this would be 5 ln of the absolute value of x, and then don't forget your plus c. All right, so we have the fundamental theorem of calculus again. And this is one of those properties that we talked about, that if you're going to integrate, have a definite integral from a to b, so you have 2 endpoints, you can find the integral and evaluate your integral function at b and evaluate it at a and then subtract it. And so essentially what we're doing, let me draw a picture of what's happening here. You have some kind of function, right? And this is a, this is b. When you find capital F of b, you're finding all of this area here, which is the area that you're looking for plus a little extra, right? Plus this little extra piece from a 0 to a. And so when we subtract the f of a, we're subtracting off this space, that area, which will just leave us the area underneath. All right, so we're going to go ahead and find the value of each definite integral. We talked about how to do it in terms of geometry. So now we're going to talk, because I know you could figure this out with geometry, but we're going to talk about how to do it algebraically. So the integral of 10 is 10x. And then technically it's 10x plus c, right? Plus a constant. And we're going to evaluate this function. So we draw a big line saying, hey, we're going to evaluate this from -2 to 4. And so the first thing you're going to do is you're going to plug in your 4. So just in for x. So this would be 10 times 4, which is 40, plus a constant. And then we're going to plug in -2. And so that would be 10 times -2 is -20 plus a constant. And we are subtracting this area off of this. And so what's going to happen here is you're going to have 40 plus a constant plus 20, and distributing that negative there would be minus a constant. And these two constants are exactly the same. And so the constants are going to make a 0, and they're going to simplify themselves out. So this is just 20 plus 40, which is 60. The area underneath of that curve. If it has a height of 10 and it has a width of 6, we would just do 10 times 6 and get 60. But now you can kind of see algebraically what in the world is happening there. So because those constants simplify themselves out and make a 0, you technically do not have to include the constants on a definite integral. So definite meaning there's two endpoints. If it's not a definite, if it's indefinite, you have to include the c value saying, hey, there could be some constant going on here. But if we're going to evaluate a specific area, those constants will simplify themselves out and essentially become like null and void. All right, so here's the next one. Integral from 0 to 1, x squared plus the square root of x. And so let's go ahead and take the integral first. So x, add to the power, divide by the power. This is x to the 1/2, right? If you ever need to just write that down so you can see. So add to the power, that would be 3/2. Divide by that power is 2/3. And then because it's a definite integral, I technically do not have to include the c. And we're going to take this right here and we are going to evaluate it. That's what this big bar means. We're evaluating from 0 to 1. So we're going to plug in 1 and then plug in 0 and subtract those two values. So when you plug in 1, 1 cubed times 1/3 is just 1/3. When you plug in 1 here, 1 to the 3/2 is just 1 time or plus 2/3. So that value will be just 1. And then you're going to subtract, I'm going to switch colors, we're going to subtract plugging in 0, and you have to subtract both pieces, so kind of put that in parentheses. So plug in 0, that'll be 0. Plug in 0 here, that's also 0. So we're subtracting 0 plus 0, so we're subtracting 0. So the value of this integral is equal to 1. So the area underneath of this graph from 0 to 1 is just equal to 1. All right. Up next, we have the integral from -pi/4 to pi/4 2 secant squared theta d theta. And so remember the 2 is just a constant, right? And whenever you just have a constant, you can move it from inside to outside so that you don't have to worry about it in your integration. So this is going to be 2 times this integral. The integral of secant squared, if you need to look back, secant squared is tangent of x. And then we don't need the plus c because it's a definite integral and it's going to evaluate from -pi/4 to pi/4. And then whatever we get there, we're going to multiply it by 2. Technically, you could put this 2 back in right now if you wanted as well. That's probably what I would do. So I'm going to go ahead and put the 2 back in there now. So I'm going to evaluate 2 sine of x, or 2 tangent of x at pi/4 and -pi/4. All right, so at pi/4, the tangent of pi/4 is just equal to 1. So this would be 1 times 2. So that's 2. And then we're subtracting tangent of -pi/4. Well, the tangent of -pi/4 is -1. And negative 1 times 2 is negative 2, so that'll turn into a plus 2. So 2 plus 2 is 4. So the area underneath of this 2 secant squared theta d theta curve from negative pi over 4 to pi over 4 is actually just a nice number 4. All right, I'm going to have you hit pause and see if you can do part D on your own. So hit pause. When you're ready, hit play, and I will show you the solution that I got. All right, so here's what I have for part D. So I split this into 2 sections here. So t to the negative 1/2, and then that actually was just a minus 1. So my integral is 2t to the 1/2 minus t, and then evaluated from 9 to 4. So when I plug in 9, this is the square root of 9, which is 3. 3 times 2 is 6. And then plugging in another 9 here, so 6 minus 9 is that first piece. Plugging in 4, the square root of 4 is 2. 2 times 2 is 4. And then 4 here, that would be another 4. So the second piece is 4 minus 4, and we are subtracting those two. And so when you do that calculation, you get negative 3. Hopefully that one went all right for you. All right, on to a few more examples. Last page of notes. Woohoo! All right, so we have the integral from 0 to the ln of 5 of e to the x dx. So the integral of e to the x is just e to the x. Remember, you don't have to worry about the plus c because this is a definite integral, and it's evaluated from 0 to the ln of 5. So we're going to plug in the ln of 5, plug in 0. So this is e to the ln of 5, and then it'll be minus e to the 0. And so I didn't have you do this one on your own because I don't know if you remember what some of these things equal. E to the ln of 5, that is just equal to 5. And then anything to the 0 power equals 1. So this is minus 1. So this area is also equal to 4. All right. Same thing over here. We're going to be working with some e's and natural logs. So let's see what we have here. The 3, remember, is just a constant, so you can just pull that out front. So you can think about this as 1 over x. So the derivative or the integral of 1 over x is the natural log of the absolute value of x. And yes, you do have to have those absolute values just in case, because if we were evaluating from like a negative at some point, we would have to make it positive because you can't take the natural log of a negative number. And this whole thing evaluated from 1 to e squared. So we have the ln of the absolute value of e squared minus the ln of 1. So e is positive, and when you square it, it still stays positive. So these absolute values are good here. So this is just the ln of e squared, and the ln of e squared is just equal to 2. You can think about it as a power rule. The 2 comes in front, and the ln of e is just 1. So it'd be 2 times 1. The natural log of 1, I didn't put the absolute values here because I kind of did that already, right? Absolute value of 1 is just 1. So the ln of 1 is just equal to 0. So that's 2 minus 0. And that would be equal to 2. And as I'm doing this, I realized I missed something because I still have the 3 in the front. So let me go ahead and I'm going to change colors and add that back in. So you should have a 3 there, right? Should have a 3 here and a 3 there. So this will be 3 times 2, and this would be 3 times 0, which is still 0. So instead of 2, this is actually 6. Whoops. So be careful of those constants. They're easily forgotten. All right. And last but not least, we're going to do kind of a new take on the fundamental theorem of calculus. And when they say it's a new take, what's going to happen here is we are evaluating, but if you look at all of the things we are evaluating to, they all have variables in them. So instead of evaluating to a constant to a constant, it's a constant to a variable. And so if you just take the if you take the integral from any constant to an x and then take its derivative, you're just going to end up with f of x. Notice this is f of t, and so you're just essentially changing, as you're plugging in, you're changing the t's to x's, essentially. Same idea here, but this is when it's not just an x, maybe an x squared or a 2x, and we'll talk about that small difference. So these look kind of complicated, but at its core, it's really not that bad. So because it's the derivative of an integral, and those are opposite operations, you're just going to end with x squared plus 1. So instead of t squared plus 1, the x goes in, x squared plus 1. That's it. You don't have to worry about a plus c because you took the integral and it would have created the c. And then when you take the derivative, it would take the derivative of the c, which gets you back to 0. So no need to worry if you're doing integral and then the derivative, you're essentially like squaring something and taking the square root of it. And so we just have this variable change that's going to happen here. All right, next one, from a constant to a variable, taking the integral, then taking the derivative. So this will just be 5x minus 3. All right, and then when this changes just slightly, look at this piece here. We're going to 5x squared instead of just an x, but we are going from a constant, taking the integral, then taking the derivative. So this would be, replace the t with 5x squared, so 5x squared plus 1. And then you have to do one more step here. You would have to do the chain rule. Because of the derivative, you have to multiply by the derivative of that thing. And so the derivative of 5x squared is 10x. This is the chain rule happening. Chain rule. And so you just plug that in for t, but then you have to chain rule it. So for example, that's what's happening here. If you go to something else, it's the function at that point, f of u, but times by the derivative of u. That's the chain rule happening. All right, so then you just distribute this. So that would be what, 50x cubed, and then plus 10x. All right, and last but not least, we have going to a 2x cubed, and we're going to just plug that in. So you do have to plug it in terms of that will also get squared, and you have the 3 in the front. And then this also has to be multiplied by the derivative of 2x cubed, and the derivative of 2x cubed would be 6x squared. And so on the AP exam, this would be a multiple choice question, and they would give you this one without this piece. Like they would simplify this, and that's what most students pick because they forget that if it's not just an x, if it's something else, you do have to chain rule because of the derivative piece there. All right, we have to simplify this. So this is 3 times squaring this. 2 squared is 4. X cubed squared is x to the 6th. Plus 1, and that whole thing is being multiplied by 6x squared. So this is 12x to the 6th plus 1 times 6x squared. So we're going to distribute 12 times 6, 72, x to the 8th plus 6x squared. So this would be the correct answer. But this one right here, just this piece, would be a possible choice because they would hope that you would forget that chain rule portion there. All right, so that is it for our notes for today. So in terms of your homework in your packet, the next one, I was going to have you do this in class. And so it's a Big 10, so it's just whatever you get. All of your answers, you should have the numbers 1 through 9 completely. So I'm going to have you skip that one for now because I want you to do the circuit. So you're going to do topic 6.8, the circuit here. And it is a little bit longer, but you should have time on Monday, right? And then we will see you, well, I might see you on Tuesday if you're in the building for the ACT. Those of you taking it, good luck. And I will see you on Wednesday for sure in class. All right. Have a good one.